Hello, good morning and welcome. Today I'm gonna teach you about digital uh, electronics, and basically today we shall focus on what we call uh, numbering systems. Now, the objectives of today is to know the types of numbering systems and conversion. So by the end of today's lesson of this session, we shall be in a position to state the different numbering systems and be able to also compute the conversion from one numbering system to another. So let's dig into the topic. We have four different types of numbering systems. The first one, or the biggest one being used, is what we call the decimal numbering system. We have also the binary. I'm arranging them from the priorities or from what we use. Third one is what we call the octal numbering system. Then finally we have number 4, which is the hexadecimal numbering system. So these numbering systems have been classified according to what we call their digits, or what came to be known as the bases. For instance, in decimal number system, it has a base of 10, and by base 10, this simply means that it has 10 digits when you count from 0 to 9. When you count from 0 to 9, you'll get the 10 digits of the decimal number system. Now, the binary has only 2 digits. That means that it has a base of 2. So it has 2 digits. Those 2 digits are only 0 and 1. So it can change or vary according to those 2 digits. Now, when it comes to octal, octal has a base of 8. That simply means when you count the octal number of bits or digits, you'll get it counts or it ranges from 0 to 7. From 0 to 7. And winding up on the list is the hexadecimal, which is the biggest. Hexadecimal, which is the biggest and is the most commonly used in digital systems when it comes to microprocessor and the ICs, language programming. So this one has a base of 16. That means it has a range of 16 numbers, 0 to what we call to 9. Then from 9 we have some letters from A to F. So when you count all of them, they become 16 digits. Now let's dip into what we call conversions. Conversions of numbering systems. Here in conversions, we shall start with what we call decimal conversion. So for instance, let's dig into an example. Let's have an example where you're supposed to convert 45.35. This is a neck question to base 10. You're supposed to convert it into binary. Convert that to binary. How do you go about it? The solution: split this number into 2. So you'll have 45 plus 0.35, and all of them are to base 10. So we shall start with converting 45 into binary. So 45 into binary is the same as you divide this number by 2 by the base. Divide it by the base of which you are converting into. So divide by 2. What do you get? You'll get a result as 22. 22 by 2, that is 44. That means we have a remainder of 1. Then take your 22, divide it also by 2. You'll get this is 11 with no remainder. Yeah, the remainder is 0. Take that 11 again, divide it by 2. You'll get this is 5 with a remainder. 5 by 2, that is 10. So that is a remainder of 1. Take that 5, divide it by 2. You'll get this is 2 with a remainder, and the remainder is 1. Take the 2 again, divide it by 2. You'll get this is 1 with a remainder, and there is no remainder with a remainder of 0. Take the final one, divide it by 2. You'll get this is 0 with a remainder of 1. Now, for division, you need to know that the last bit is the MSB. The last bit is the MSB. So you're going to write these digits starting from the MSB going upward. So this is the most significant bit, while this is the least significant bit. So when we rearrange these bits going upwards, this will give us 45 as that. For the first bit is 1, the second bit is 0, third one is 1, then we have a 1, then a 0 and a 1 to base 2. And this is 45 written in binary. The next one is 0.35. So for 0.35, let me do it over here for the sake of saving some space. 0.35 is a fraction. So a fraction, for a fractional number, converting it into binary, you simply 0.35. Instead of dividing, you multiply by the base, and the base is 2. When you multiply this, you'll get this is 0. That is 7. 0.7. Now, what you need to do is to subtract it, you see, if you have a carry out. Here, there's no carry out, so the carry is simply 0. Take the 0.7, multiply it by 2, you'll get this is 1.4. Now, when you subtract 1.4 from 1, you'll get that is a 0.4 with a carry of 1. So the answer will be 0.4, but the carry of 1. The carry of 1. This 0.4, when you multiply by 2, you'll get it's a 0.8 with no carry. Carry of 0, because in the first bit there is no carry. Take the 0.8, multiply by 2 again, once more, you'll get this is 1.6. When you subtract 1.6, you'll find out that the first bit gives you a carry, so the carry is 1, so you'll have 0.6 with that carry of 1. When you multiply by 2, you'll get this is 1.2, and the process continues, 1.2, and this when you carry out this 1, so with a carry out of 1, this 1.2 will be 0.2, the carry out is 1. So this process is endless. You can continue, so you can truncate up to that point. That means the highest bit will be our most significant bit, and the lowest bit, the endless bit, will be your least significant bit. So when you take that into account, then 0.35 will be the same as this will give you starting with the highest bit, that is point or 0.01011 to base 2, and that is 0.35 in binary. Now when you combine this thing, this will be plus that 0 point, so this will give you 1 0. Sorry about this is not a decimal point, it's just a mark. So 10101 point, the decimal part or the fractional part. There's no need of writing this base right now. There's no need of writing that base right now. So I'm gonna erase it. Sorry about that. It seems that my ink has given it a permanent stay. So this will be with a point of 0, 1, 0, 1, 1 to base 2. This base here should be eliminated, and that is 45.35 in binary. Thank you for staying by. Good day.